So this session, we're hoping to relate, we're going to tell a story that will hopefully resonate with you about some of the challenges that you face on a day-to-day basis. A lot of them Peter's mentioned, Stephanie's mentioned, and you asked from Eaton have mentioned already. So to help me tell this story, I've brought some of the aPriori rock stars up on stage from around the world. But today, they're really representing you, your colleagues, your teammates. So we've given them a slightly different title for today. We've got Dave, who's going to represent the program managers, the product managers of your organizations. We've got Rodney, who's going to represent the cost engineers, the value engineers, that team. Sam's going to represent the product development, design engineering team. And April, from our sourcing department, is a commodity manager. And so for the next 40 minutes, we've turned them into a dream team of product development. And we're hoping the aim of the session is really to inspire you with what's possible by using aPriori and the Manufacturing Insights platform. So if you were here last year, or not here at Manufacturing Insights conference in Boston last year, we're going to continue the story that we told. We're going to explore and discover some of the challenges that we discuss with you on a regular basis, faced by each role. And then we're going to really explore and uncover the opportunities that are potentially identified by using aPriori. And bringing together different teams with the right information at the right time, leveraging our cloud collaboration is really going to help accelerate product development. So last year, we developed an RC car, which we gave away. And we redesigned a sheet metal assembly into an injection molded component. And we saved 77% on cost and 82% reduction in embodied carbon equivalent emissions. So we've got a pretty high target to beat this year. And since then, as Peter mentioned and Stephanie mentioned already, the world's become a lot more complex. Developing products is a lot more complex than it's ever been. Sustainability is adding additional requirements, and new regulations and directives are just adding additional challenges and costs. Competitive pressure is always there, it's increasing, time to market is more critical than ever. And products themselves are becoming more complex, and development times need to be shorter. So where we're going, since the RC car, we've expanded into e-scooters. The reason for that, most car trips are quite short. Rental e-scooters got quite a bad reputation, as they often get discarded and don't end up in the right hands. They are often confiscated and misused. So what we want to do is leverage our brand recognition from our RC car and move into this new market segment. We've had some initial success in the US, and we want to expand into a European market. So some of the business challenges. We've got some really strong forecasted growth in the space. But one of the challenges is CBAM. So if you've not heard of CBAM, it's the Carbon Border Adjustment Mechanism. It's just entered into effect. It's adding a price of carbon, embodied carbon, on certain materials imported into the EU. So that's going to be a challenge. Shipping costs increasing. Can we nearshore manufacturing? That's been mentioned a number of times. Is that something that we can investigate using aPriori? And customers are driving sustainability. They're more aware than ever of greenhouse gas emissions and embodied carbon. So we need to make a significant reduction over the current generation product. So to start things off, Dave, how did you tackle the scooter project?
Well, we have access to data we've never had before. This is my dashboard. I have visibility of the program status in terms of how much design work's been done, but with respect to that, where we are against our carbon and cost targets, we're already over on cost. And as you can see, it's the chassis that's doing most of the damage there. So we got to go fix that. I can also see my weight target as well, because we can't just spend money on making the thing more cost effective at the cost of weight. And carbon is overrun as well, as you can see, so the chassis, again, is a culprit for that. We've got to go and fix that. So we need opportunities for cost reduction during the design phase. And on my AP Analytics dashboard, I also get to see those opportunities to go and talk to the team about. Here I can see for every component, as it's being designed, the dollar per kilogram of weight of that component. And therefore I can more easily spot the outliers. This component here is more expensive per kilogram. This component over here is just heavy. That's an obvious opportunity for carbon reduction. I can also drill down to see what all the manufacturability issues are behind them, because they drive cost and carbon too, and talk to the team, maybe look at supporting the design teams with feedback on what they should be focusing on. This graph here takes those same components now during the design phase, plotted on a graph of cost per kilogram versus CO2 per kilogram. In other words, the bottom left-hand corner are components that are good. The periphery of this diagram are opportunities for cost and carbon reduction. That one there is a carbon reduction opportunity. The ones up here, cost reduction opportunities. And I want the teams to go and look at all those peripheral components and start doing something about it during design. I also can have visibility of the procurement angle too, because all these components add up to an embodied carbon for the whole scooter, and I can see what the implications are for each manufacturing region of the world that we are interested in. And as you can see at the left-hand side, the Nordics, Norway and Sweden, that's nice and carbon effective. The right-hand side, the Far East, China and India. So clearly we want to make everything over in Norway and Sweden, but of course that comes at a cost. Now the beauty here is that we have a balancing act to do, but when I have visibility of my cost target and my CO2 target and how I'm against them, I can start to make trade-offs. I could actually go to Norway if carbon is our problem and spend a little bit of money to get that target done at the risk of a little bit of cost. Because it's a complicated equation, we are using ICP, or internal carbon pricing, that AP Analytics can work out, that incorporates the CBAM cost as well as other elements that go into it, that basically puts a dollar value on the carbon footprint. So now this red line is a nice, simple way for us to get a gauge on the real implications of cost and carbon in different regions of the world. Now in there, I'm looking at Eastern Europe as the obvious place for our European market to go, but Brazil stands out there too. And that's interesting because we also have a North American market. And Brazil is kind of a place where we'd love to go, and maybe we could do a bit more maths now to work out what the duty and tax and logistics implications are of manufacturing in Brazil and supplying to North America and to Europe. It's a complicated equation that we just need to get insights into now, because it takes a while to do all this planning. Bringing the team together to actually take these opportunities and realize them is difficult, so we use AP Workspace. We use that to collaborate among different team members. And these team members get to have conversations, and I have visibility of those conversations because they can make trade-offs. They can make decisions in a vacuum that have implications for April. The design can affect the procurement challenge. I get to see what they are and have visibility for how they're getting on with things, because this is my KPI. We've got to meet our objectives.
So you've got some real impressive insights and to guide the team. So how would you have done that traditionally before aPriori?
Well, we wouldn't have. We didn't have any visibility of cost or carbon until it was too late, obviously. Do you have a slide on that?
I do.
You do? Oh, beautiful. Great. So we didn't have any visibility. It was too late. We would only find out the cost when we got to the supplier and they gave us their quotes, which was clearly too late to make any sort of dent on it. So we certainly couldn't identify opportunities too. And even if we could identify opportunities for carbon and cost reduction, it was impossible to collaborate on the real detail of that. So we'd make a decision about the design, and then April would have a real problem in supply chain for processes that are difficult to get suppliers for. Complicated equation that we couldn't get our heads around.
What kind of a difference is aPriori made here?
Well, first of all, we used to miss our targets every year. In fact, most companies do, but we are hitting our targets now. We set a target cost and we get there immediately. Same with carbon, because it's becoming important for our business. We've set objectives to the marketplace. So we get them done. Because we can actually realize opportunities in cost and carbon improvement, because we get the insights early and we have time to do something, we're actually overachieving our targets now for the first time in our history. which means I can sleep at night.
Good stuff. So Sam, you've got the guidance from product management. Talk us through your workflow when it comes to the new scooter design.
Sure thing. All right, so starts off, I get an email, and I can see it's a message from my buddy Rodney in cost engineering. And what's nice is I don't have to search through old Teams messages. Everything that's relevant to the scenario I'm looking at is all loaded in AP Workspace. And I can quickly visualize that aPriori Rodney analyzed our existing assembly at the new higher volumes, but we're still coming in over our cost targets. And we're over on weight and CO2 as well. So I need to go back and redesign this part. And my first idea is to reduce the complexity by lowering part count and going with some custom extrusions. And that decreases my cost, sustainability, and weight. But I'm still coming in a little high, mainly due to that large custom extrusion there that's making up the majority of the cost. So maybe I want to consider a casting. And instead of spending the time going and redesigning, I'm just going to shrink wrap that assembly into one part and then rerun that analysis in aPriori. And obviously, this isn't designed for a cast part, but I can quickly see from a directional standpoint if this is going to make sense to spend time on in CAD. So I'll launch that directly into AP Design, specify my parameters. I'm staying with aluminum 2024 that I used in our existing product. And I can see that I'm going in the right direction from cost. I reduced that from our extruded weldment there. But I want to now get an idea of, OK, when I go back to CAD, what do I have to take into account when I design this cast part? So I can look at any sort of issues that aPriori is highlighting. And if I need to understand why something is critical, I can always open up a tooltip to let me know why that's important. Under the Investigation tab, I can take a look at the special mold tooling to understand what complexities are involved with this current part. So how am I going to redesign this to avoid that complex tooling? And back in the CAD system, you can see I now redesigned this, eliminated those complex tooling areas, added in some draft angles, and now I'm going to just repeat that process, launching into AP Design and specifying my same parameters as before. And what's nice is that this is only taking me a few minutes, right? I live in CAD system most of my day. I can just quickly run and understand how that's going to impact my part. Right away, I can see my DFM risk is low, so that improved. My cost is decreased a little bit, which is nice. I'm a little higher on that weight and sustainability, but these are all trade-offs that I can then deliver to my project manager, Dave, and he can deliver the best product possible for our customers. And if I want, I can start playing around with tolerances now. So maybe we had a quality issue with the stomp pad before. We had poor adhesion. So I want to understand how a flatness tolerance will impact the cost of this part. When I reanalyze, I can quickly understand what tolerances are driving any sort of specialized finishing. In this case, a machining operation has been added. And I can understand, how do I have to back off that tolerance in order to eliminate that as an option? So once I'm confident with my design, maybe I'll have some tweaks here and there. But I'm in a good space for now. I'm going to come over and tag April in procurement to let her know that we're looking at a casting part. But do we have any extrusion or casting suppliers who we're really confident with currently? I also want to ask her about the material choice, right? Our current selection was aluminum 2024, but maybe there are some similar alloys that we get better rates on from our supply base, and we can extract a little more cost out of this part. And finally, I'm going to tag Rodney in cost engineering, let him know I'm confident with my current design, and he can perform a full, robust cost analysis, maybe do some other trade-offs to understand really what's going on with this part. And now that I'm done, I can go back and work on some other redesigns.
Thanks, Sam. So I can see you've really learned a lot about those designs by running them through AP Design. So how would you have done that before?
Yeah, shorter answer is we really couldn't, at least not to that extent. Our design process was really quite sheltered, and we'd rarely get feedback from other departments until after we completed the design.
So using this platform approach, what's this new way of working really enabled from your perspective?
Well, as you saw, I can run through way more design iterations than I could previously. So I can look at cost, manufacturability, and sustainability insights, and that allows me to eliminate or pursue an option without waiting weeks for feedback from other departments or from suppliers. And now I can pull in my other stakeholders to collaborate earlier in the process than I did before.
Great. Thanks, Sam. Now, Rodney, in value engineering, we've already heard you've been inputting into the project, both from product management and design engineering. So lots of collaboration already. Tell us about the role you played in developing the e-scooter.
Sure, no problem. So I'll start off. Dave mentioned at the start he found an outlier on the chassis, and he asked me to investigate it as part of my role in value engineering. So my first port of call here is I'm going to scale that up to the projected production volumes to see will the existing process scale with our projected volumes, and I want to get that answer as quickly as possible. And the simulations are very quick and concise to run, but I want to see it's a multi-variable equation. It's not just cost with trade-offs. But you can see we can scale a little bit with volume, but we're going to fail on our sustainability goals and our weight goals, so I can notify Sam that it's a candidate for redesign. But that's a two-way street. So as Sam mentioned, he notified me in AP Workspace that he's looking at a casting now, he's redesigned it. And we mentioned there an alternative material. So again, value engineering, I need to determine if it's economically viable to do so. So I'm going to start to look at this component as an alternative material. Does it make sense? So I can look at that from not just a cost perspective to see what the implications of the source material are, but also from the sustainability perspective as well. These are trade-offs. What lever I pull will have an impact on another one. And again, it's a multi-variable equation, and I can get those results. But I first want to see, is it viable to take forward and investigate further with people's resources and time? So again, I want to see these in an easy, digestible manner. So I'm going to run these as that comparison analysis again, so I can see those trade-offs very quickly, very concisely, and get to that value assessment as quickly as possible. We don't want to waste time. So you can see here that there is a small improvement on the actual cost, but there's a significant improvement here on the sustainability. So I can tell Sam that's a viable option to go with and let him continue. But because he's told me he's designed this as a casting, my thing is I want to get the optimal manufacturing process as quickly as possible, so I can run this through various manufacturing methods and methodologies. So I'm running this one as a die casting to see if that's a more viable solution. We have some sand casting productions from the RC car from last year, but I want to see, is that our optimal process to meet our cost targets? So we can see the process here, and there's a new should cost, but again, I want to do that trade-off analysis. Should I make it in-house or should I buy it? What's my capital investments? These are all things that I need to understand to make those decisions going forward, and I want to get to them as quickly as possible. So you can see here in this case, we have significant savings in both cost and carbon as well. So I know die casting is my optimum process here. But because of the speed of these, April had mentioned to me in conversation that she often feels for prototyping, she pays above the fair market price, and it's an assumption, it's a feeling. I quickly ran a simulation while grabbing a coffee on stock machining, and now I can pass downstream some indicative prices as what we should expect from a should cost sort of aspect. Now, as a value engineer, I want to get to that optimal manufacturing process as quickly as possible, but I want to see it in much more granular detail. Once I find my primary process, I want to optimize and refine it and effectively mitigate risk. I want to avoid challenges in the manufacturing process. So here we can see I'm looking at a wall thickness issue that's been highlighted. We're under the 3 millimeter tolerance here, so there's locations. And I can use aPriori to actually find those locations. This is going to increase scrap either for me, an in-house manufacturer, or the supplier. And I can identify where these regions are through AP Pro. Now, AP Workspace, I can go in and highlight that issue directly visually for Sam in design. And I indicate where the issues are, but also the implications of that issue. It helps build his knowledge and get to those decisions. And he can refine his design before he releases it, because we don't want to waste time going through lengthy engineering change order processes. So Sam can go to that directly and make any amendments needed. But that's upstream. One of the other things is I can now optimize my time as a value engineer and look at other options I wouldn't be able to do. So in this case, the material thickness gave me the idea of, well, what if we did this as a plastic part? We can start to test assumptions and theories and look for viability elsewhere within that value rule. So I can see this part, there's some viability, but I don't want to waste time for Sam redesigning the part. So in this case, I'm going in and I'm actually going to change the nominal wall thickness without wasting his time doing CAD changes to see, is there viability in taking this forward and investigating that and applying those resources before we do any FEA analysis or wasting time. So we can see there is some degree of viability here. We started off with a cost just below $39, and we're now down to just under $31. So when you scale this across our volumes, there's significant savings to be had there. So I can notify Sam of this and say, we are making improvements both on cost, but also on our carbon as well. So can we please investigate? And I'll collaborate with Sam and he'll give me some feedback back and forward and we can refine that without too much effort. And I can actually then see, is it a viable solution? So the updated design here, we can see, yes, we made significant improvements on our CO2, but our cost has now gone the other way. So it's no longer a solution for us. So we can eliminate them much earlier in the process before we get to a gate review. Now that's upstream support, but it's a two-way street, so I can pass that downstream as well. So now we have done the make versus buy. I can now notify April in the supply chain and give indications of what the actual requirements are from the supplier, from manufacturing requirements. So what types of equipment, machinery, et cetera, are we going to need to optimize her supplier selection when she comes to have those discussions around her sustainable sourcing strategy as well.
Very impressive, Rodney. So we know value engineers are usually massively outnumbered by design engineers. So that potential bottleneck, is that the main issue you had before?
It was a significant issue. Previously, we would have been used as the resource to pass information on should cost, et cetera, both upstream and downstream for make versus buy. And it very much was a challenge of, let's just get it done. The resources were there, we just had to get an answer and get things into production. But because of certain things we can do now, where Sam can eliminate some of the design challenges he would have requested information for, it frees up my time more now. So it's now gone from a let's just get it done to let's get it done right. So we can optimize more and expand on that.
So what would you say the main benefits are that you found by leveraging the Manufacturing Insights platform?
It's a single safe source of the truth. So everybody's collaborating on the same scenario. And often value engineers, multiple engineers will be on a project. So we can hand off information and detail the assumptions and calculations we've done within that, and everyone can work on it. Also, the fact is, it's fact-driven decision-making. So it's no longer down to someone's experience, someone's skill sets. It's black and white, it's there in front of you. So it gets to that decision-making much, much faster, but also for new insights. I'm not an expert in plastic molding, but I could go in and learn more things and try more things and learn from the tool without having to be an industry expert in that field. Expand my knowledge.
Great. Thanks, Rodney. So, April, in procurement, typically you're the last to find out everything, but we've already heard from you quite a lot. You've been contributing, giving your insights, your perspective to help craft and influence the design and material selection. So, how is using the Manufacturing Insights platform? Tell us about how you can elevate your position.
Yeah, thank you, Mark. So as you had mentioned, I was able to guide some of the colleagues on a more cost and carbon-friendly alternative. And the way that I was able to do this was through a material consumption analysis within AP Analytics. So it allowed me to take a look at how we're using aluminum alloys and what we were using the most of. So this really outlines and provides an outlier of, we're using a lot of this 6061 aluminum. Perhaps we can use that as leverage to getting a significant discount for increased usage. It also gives me a little bit of an indicator of further analysis should we have some high demand or price increases on that 6061, that maybe I should look into alternatives or diversifying the supply around that particular material. So the next thing that I did was I took the feedback that I received from Rodney around the manufacturing process guidance, and it allowed me to only target the suppliers that meet the specific criteria to do further analysis and try and target where exactly I want to go in terms of locations for this particular part. So because we were looking to expand into Europe, a lot of the selected areas were from known suppliers that are in Europe. And just to have a little bit of comparison, we also tested a little bit in Asia. To do this, we performed a matrix analysis, which basically allows you to select all of the digital factories that are required, pick the annual volume and batch size, roll it up into one scenario, and analyze it in bulk. This allows me to automatically, within minutes, be able to analyze costs for all of these regions and determine really where I want to go. This roll-up also makes it really easy to determine that Vietnam seems to be the option to investigate further for this particular part. Moving on, once the part design was finalized, it was time to secure the production with the supplier. So we sent out a few quotes to Vietnam, our top-tier choice, Hungary, and Portugal, just to give a flavor here. And we had a few discrepancies come with the Vietnam quote, one of them being an overhead rate that was 30%, that was higher than average than our typical quote suggested. And the supplier said it was due to a 30% increase in energy consumption. So I went into the scenario and looked at the energy consumption within our direct overhead rates and did a manual override just to really evaluate and double check that that specific increase was really valid. Once I did that, I recosted the part, and while there was an increase in energy consumption, it really didn't have a direct impact on cost. So I can take that data back to negotiate with the supplier and make sure that we're actually meeting the quote to our specifications. And as you can see, I also have a view of the override summary, so I can take a look just to double check my work and make sure that when I'm negotiating with the supplier, I really have that in my back pocket and can use that as fuel to guide the negotiations. So now that I've had all of that time up front really working on addressing some of those issues, I have more time to focus on more strategic initiatives, such as the final assembly and production location for the e-scooter. So going back to the report that Dave had showed earlier, you can really see that we're testing those specific locations and looking at the first metric of the fully burdened cost. So as you can see on the far east, it's looking like the costs are good, but that's not really the full picture here. So we're going to take a look at the total carbon to really understand where it all lies. As you can see, while it's more cost effective in the far east, the total carbon is too much. However, applying the internal carbon price metric, I can easily pinpoint that Hungary, Portugal, even Sweden are showing some areas of potential locations to identify further.
Very impressive, April. So how would you have tackled that before?
Honestly, I was usually brought in late to the game, so I wouldn't have that collaboration with design engineering ahead of time, and usually it was only unless there was a supplier problem. So a lot of that collaboration that was happening downstream really impacted meeting our target costs and target carbon as well. So usually that would lead to some sort of supplier feedback that would then come back and have a costly engineering change order that would take place.
So what's this new platform approach really enabled from your perspective?
Yeah, so by being able to provide that feedback up front, I'm more proactive and less reactive to problems coming up downstream, which gives me more time for that strategic focus to elevate into more strategic sourcing. And then also using that data to have the fuel to guide those fact-based negotiations and have really easy to access data at the palm of my fingertips to have a really transparent conversation with my supplier.
Great. So the team's done a great job, Dave. They've been able to leverage the platform, share their insights, their domain-specific expertise, and really accelerate the product development cycle and reduce iteration loops. So what does that mean to you?
As I said earlier on, thanks to the fantastic efforts of these guys, I sleep at night now. And as you can see here, the green circles on the chassis show that we're back on track for cost and carbon, problem solved. And then the next step now is to go to the braking system. That's our next problem we'll go and get onto. Now, to get to this point, we've had to analyze thousands of scenarios. I mean, it's not just this product. Do we use lots of resources to do that? No. We use aPgenerate. And in the background, aPgenerate goes off to our PLM system, grabs cab data at the right stage in its product lifecycle, its right maturity, like this component here, and just runs the analyses in the background. Those analyses take data from PLM as well about the component's material and its process group and other factors as well. Run the simulation while I sleep, comfortably, I might add, and produces results that go back into PLM, the same results that these folks have been looking at as well. You can also see down the bottom there also maintains a link that takes people from PLM to the detailed insights that show cost drivers and what the DFM issues are that are important to them. So our PLM now becomes the real single source of the truth, the real digital twin of everything, not just the product definition. And we use that in stage reviews. Our gate reviews take cost data and carbon data as well into account. This information then gets rolled up into its configuration context inside PLM because we have lots of different product variants, different countries we're selling into, we have different configurations for each of these countries. Hugely complicated equation. Making that data available to our PLM is good for other people in the business. We're not just the only ones. Very powerful asset. It also speeds up their job too.
Excellent. So when it comes to complete product development projects, where were the difficulties before and how has aPriori made a difference?
Well, that link to PLM didn't exist before, so everything was manual. And those people that relied on the data that we had at our fingertips was either typed in wrong or took a long time to do or just never quite got there. So we removed a lot of the error-prone stuff. As a result of that in the previous existence, we had limited business intelligence. So therefore people at the sea floor were making decisions in a vacuum without knowing what the real implications of a strategy would be in terms of cost and carbon, the things that we care about, the things that, well, I get paid on. But with our new world, with our manufacturing insights platform, we are avoiding cost overruns. In fact, we're overachieving. We're hitting our carbon targets. And we have real-time visibility to progress because that's what's going to make our business work.
Excellent. So the team's done a great job. They've been able to look at a number of different iterations and not only improve upon, but also innovate, try new ideas and validate them or rule them out completely. So you can see all of the different iterations that have been gone through and leveraging the departmental data and their expertise and this holistic design approach really enables agile product development. So this year, we managed a cost reduction of 80% and an embodied carbon reduction of 64%. So to summarize, obviously I expect a carbon and cost reduction using aPriori. We've lowered the cost, we've reduced the environmental impact. It's obviously added value to our products and increased our profits. But we're able to innovate. We're able to fuel that funnel and add new ideas, look for opportunities for innovation. Early validation means we can add value, and everything we run through aPriori adds value. That's intellectual property. Design decisions are intellectual property. We're removing traditional constraints so you can try out different things without necessarily having the knowledge there. And collaboration is critical as products get more complex. We discussed that earlier. Having the single source of truth means the data is all in one place, and having the connection to PLM, we can really augment that PLM data so that you can really benefit from that investment and reimagine your digital twin.